All right, so this video is going to be about conditions for a triangle, looking at sides, so impossible, unique, or not unique. In class, you might be given a task like this: create as many triangles as possible using the line segments below. A line segment cannot be used more than once in a triangle. If you were to build with those conditions, you would find that there are only 20 possible combinations. But out of that 20, only 11 can form triangles. So the question is, well, why can those 11 form triangles but the other 9 can't? So why is that? Why can only 11 out of 20 form triangles? Well, because the sides of triangles have constraints or limits. So if we were to actually look in class at trying to build triangles, we might use these plastic sticks with holes in it that allow us to construct sides of certain lengths. So this would be a 3 side, this would be a 4 side, this would be a 9 side. And if we try to build a triangle with sides 3, 4, and 9, you find that the two smaller sides will never reach to form the third vertex or corner. Okay, so if you try to bend this one and bend this one down and bend that one down, they'll never meet. There's always going to be a gap. If we were trying to build another example, trying to build a triangle with sides 5 units long, so this would be 5, another side 5 units, and a 10 unit, you would find that the two smaller sides will only touch when they overlap in the larger size or side. So if you were to pull this down and you were to pull this down, they would meet right here. And that would not form a triangle. But when you're trying to build a triangle with, say, 3 units long side and a 5 unit long side and a 6 unit long side, then you can connect them. You will have 3 vertex or 3 corners, and that will make a triangle. So looking back, what do we notice from the combinations we created? Is there a pattern or rule about what sides will make a triangle and what sides won't? So if we look at these 11 versus these 9, these 11 will make a triangle, these 9 won't. Is there something in these numbers that can give us a rule? So making conclusions, if we look at these numbers, if we look at the combinations, the ones that form triangles and the ones that don't form triangles in terms of their sides, you find that if the two smaller sides add together are greater than the largest side, then the 3 sides will form a triangle. So if you look here, 2 plus 2.5 is 4.5, and that's greater than 4. 4 plus 5 is 9, which is greater than 6. 5 plus 6 is 11, which is greater than 8. But if the two smaller sides added together are less than or equal to the largest side, then the 3 sides will not form a triangle. So if you look here, 2 plus 4 is 6. That's equal to the largest side, so that won't form a triangle. 2 plus 4 is 6, is less than 8, so that will not form a triangle. And that's true for all of these over here. So what we discover is that there is a theorem in math called the triangle inequality theorem. And it states that the sum of the lengths of the two smaller sides of a triangle must be greater than the length of the third side for the 3 sides to form a triangle. So if we're looking at A, B, and C, okay, and I know in this one it may appear like B is not the smallest side, but that's okay. We're just going to go with it. We define that A plus B has to be greater than C. The two small sides together have to be greater than the longest side. Okay? So we have triangles with conditions. So we're going to look at some examples. Okay? If you were given an example like this, determine if it is possible to draw a triangle with side measures 11, 12, and 17. Well, 11 and 12 are our short sides. 17 is our longest side. If we add 11 and 12, we get 23, which is greater than 17. So these sides would form and can be drawn, or a triangle can be drawn with these three side lengths. So this would work. 11, 12, 17 would work. Here's another example. Determine if it is possible to draw a triangle with side measures 4, 10, and 14. So we know that if we were to take the two smallest sides, 4 and 10, add them together, and compare them to our longest side, we'd find that 4 plus 10 is actually equal to 14. So therefore, no, it would not, or a triangle can't be drawn with these three sides. So if we were to look at another example, it says determine if it is possible to draw a triangle with side measures 2, 7, and 13. We would find that our two smallest sides are 2 and 7. Our longest side is 13. If we add 2 and 7 together, it would be 9, which is less than 13. So no. Therefore, a triangle cannot be drawn with these side lengths. Okay. However, you don't only have to know if a triangle can be drawn with certain sides, but you have to know how many triangles those certain sides will make. So when we think about this, we have three choices. Either it's impossible, which means that no or zero triangles can be drawn. It's unique, which means only one triangle can be drawn. Or it's not unique, where more than one triangle can be drawn with those conditions. So let's practice some of these. We're given certain sides. We're asked if that would make a triangle or not, and if it's impossible, unique, or not unique, or will it make zero triangles, one triangle, or more than one triangle. So with 4, 5, and 11, would that make a triangle? The answer is no, because 4, 5 added together, which are the small sides, is 9, and 9 is less than 11, so this would be impossible. If we look at 1, 3, and 4, again, you cannot make a triangle out of that because 1 and 3 add together to make 4, and it has to be greater than the third side, and the third side is 4. So again, this is impossible. And then on this page, or on this slide, we would look at 7, 8, and 16. 7 and 8 add together to make 15, which is less than the larger one. So again, this is no, impossible. All right, well, let's consider some other situations. If you were just given one side, 4, well, can one side form a triangle? Well, the answer is yes. If we only have one side, then we could pick the other two sides. And as long as they fit the situation of that the two smaller sides are greater added together than the larger side, that would work. So this would be not unique, meaning that you can form many, many triangles with this situation. For 4 and 5, that's a yes again. As long as we've set the limits, you can form a triangle with a 4 and a 5. It's just that whatever the third is has to fit within that same theorem, that the two smaller sides have to be greater than the larger side. So this is also not unique, meaning you can draw more than one triangle. Well, what about 4, 5, and 7? Well, if we do 4, 5, and 7, we look at 4 and 5. 4 plus 5 is 9, which is greater than 7. So this is also a yes. But how many can it draw? In this first one here, we were able to point out that you could draw many because we only had the one side. In this one, you can draw many because you just had two sides. But now we have these three. So how many can that draw? Well, that's the question we need to answer. So this is a series of triangles created with the limits of 4, 6, and 9. 4, 6, and 9 will draw a triangle. 4 plus 6 were the two smaller sides, which are the two smaller sides, add together to make 10, and 10 is greater than the larger side, which is 9. So these are all triangles, but they look different. But the question is, are they really different? Are they the same? Are there differences? Well, if you actually look at the triangles, you would see that actually all the triangles are just identical copies of each other. They have all the same side lengths, and they have the same angle measures. If we actually measure these with a protractor, all of these angles would match up. So this angle here, which goes with the 4 and the 9, would match this 4 and 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 9, and this 4 and 9 angle. When I mean 4 and 9, or when I say 4 and 9, I mean the angle created with those sides. So all the angle measures are the same compared to each other. Doesn't mean all the angles are the same in each triangle, but it just means that if you were to pick a corresponding angle, they would be the same. So this corresponding angle and this corresponding angle would be the same. So what you have is we don't have 6 different triangles. We just have one triangle. They are the same triangle, just in different positions. So there's only one triangle you can make with with 3 specific sides. So when we look back at 4, 5, and 7, since these work that fit the theorem, that the two smaller sides are greater added together than the larger side, it would form a triangle, and that triangle would be unique. You can only form one triangle with those conditions. Okay, so here are the rules for constructing triangles given sides only. If you are given 3 side lengths where the sum of the 2 shorter sides is less than or equal to the length of the longest side, you cannot draw a triangle. It is impossible with those conditions. If you are given 3 side lengths where the sum of the 2 shorter sides is greater than the length of the longest side, you can draw a triangle, but you can only draw one. It's unique. It's unique.